In this video, we shall have a good introduction to complex numbers. And by the end of this video, you will know what a complex number is. And you will also know how to add, subtract, multiply, and divide complex numbers. Now, first of all, what is a complex number? When you hear the word complex, you might think that the whole thing is difficult. But in fact, complex numbers aren't that difficult. A complex number usually takes the form a plus ib, where a and b are constants, and then I is equal to the square root of -1. Now, in complex numbers, the part that contains a is called the real part, and the part that contains ib is called the imaginary part. Long ago, it used to be difficult to find the square root of a negative number. But after discovering that the square root of -1 is equal to I, it became possible. For example, we can find the square root of -9. First of all, this can also be written as the square root of 9 times -1. And then we can separate this as the square root of 9 times the square root of -1. This will be equal to the square root of 9 is 3 times, now we know that the square root of -1 is equal to I. So this will be equal to 3i. So that's how you find the square root of a negative number. For the examples of complex numbers, we can have 3 plus 7i, and also we can have 1 minus 2i. Notice that we write I at the end. Now let's see how we can represent complex numbers. The first way of representing complex numbers is the rectangular or Cartesian form. In the Cartesian form, the complex number can be represented as a plus ib, or it can be represented as a, b. For example, we can have a complex number z equaling to 3 plus 5i. The second way of representing complex numbers is the polar form or circular form. In the polar form, the complex number is represented as r open brackets cos theta plus I sin theta, where r is the magnitude or modulus of the complex number, and then theta is the amplitude. And lastly is the exponential or Euler's form. In this form, the complex number is represented as r raised to the power of e and then to the power of I times theta. Now let's look at the addition of complex numbers. If you have the complex numbers z1 equaling to a1 plus I times b1, and then z2 equaling to a2 plus I times b2. In this case, if we are to find z1 plus z2, this will be equal to a1 plus I times b1, and then plus a2 plus I times b2. And if we open the brackets, we shall have a1 plus I b1, and then plus a2 plus I b2. And now what we need to do is collect like terms. Therefore, we shall combine the real parts and also combine the imaginary parts. So we shall have a1 plus a2 and then plus I b1 plus I b2. This will give us a1 plus a2 and then plus. Now what we need to do is pull out I because it's a common factor. So we shall have I times b1 plus b2. So let's look at some examples. Let's say we have z1 equaling to 1 plus 3I, and then z2 equaling to negative 4 plus 7I. Let's find z1 plus z2. So we shall have 1 plus 3I and then plus negative 4 plus 7I. If we collect like terms, we shall have 1 minus 4 and then plus 3I plus 7I. Now 1 minus 4 will give us negative 3 and then plus 3I plus 7I will give us 10I, and that's our answer. Now let's see how we can solve this using the formula. A1 will be equal to 1, then B1 will be equal to 3, A2 will be equal to negative 4, and then B2 will be equal to 7. So if we put in the formula, we shall have A1, which is 1, plus A2, which is negative 4, and then plus I times B1, which is 3, plus B2, which is 7. This will be equal to 1 plus negative 4 will give us negative 3, and then plus I times 3 plus 7, which is 10. And so this will be equal to negative 3 plus 10I. So you get the same answer. Now let's look at subtraction of complex numbers. Let's say we have the complex number z1 equaling to a1 plus I b1, and then z2 equaling to a2 plus I b2. How can you find z1 minus z2? z1 minus z2 will be equal to a1 plus I b1 and then minus a2 plus I b2. So this will be equal to a1 plus I b1 and then minus. Now if we open the brackets, this will be minus a2 and then minus I b2. And at this point we can collect like terms. So this will be equal to a1 minus a2 and then plus I b1 minus I b2, and this will be equal to a1 minus a2 and then plus. Now if we pull out I, we shall remain with b1 minus b2. So that's the formula for subtracting complex numbers. Let's look at an example. Let's say we have z1 equaling to negative 1 plus 2I, and then z2 equaling to negative 2 minus 3I. Let's find z1 minus z2. This will be equal to negative 1 plus 2I and then minus negative 2 minus 3I. So we shall have negative 1 plus 2i. Now if we open the brackets, minus negative 2 will give us positive 2. And then minus negative 3i will give us positive 3i. So this will be plus 3i. And if we collect the like terms, we shall have negative 1 plus 2 and then plus 2i plus 3i. Negative 1 plus 2 will give us positive 1 and then plus 2i plus 3i, which will give us 5i, and that's our answer. Now let's try solving it using the formula. A1 will be negative 1, B1 will be 2, A2 will be negative 2, and then B2 will be negative 3. So we shall have A1, which is negative 1, minus A2, which is negative 2, and then plus I times B1, which is 2, minus B2, which is negative 3. This will give us negative 1. Now minus negative 2 will give us positive 2, and then plus I times 2 minus minus 3 will give us plus 3. This will be equal to negative 1 plus 2, which is 1, and then plus I times 2 plus 3, which is 5. And so our answer will be 1 plus 5i, which is the same as the first answer. Now let's look at multiplication of complex numbers. When it comes to multiplying complex numbers, there are some things you need to know. If you remember, we said that I equals to the square root of negative 1. What happens if we square I? If we get I raised to the power of 2, this will be equal to the square root of negative 1 raised to the power of 2. This 2 will cancel with the square root, and so we shall remain with I to the power of 2 equaling to negative 1. Now what about I raised to the power of 3? This will be equal to the square root of negative 1 raised to the power of 3. And this is the same as the square root of negative 1 raised to the power of 2 times the square root of negative 1. And we know that the square root of negative 1 to the power of 2 is equal to negative 1. And then the square root of negative 1 is equal to I. Therefore, I raised to the power of 3 will be equal to negative 1 times I. And this will be equal to negative I. Now what about I raised to the power of 4? This will be equal to the square root of negative 1 raised to the power of 4. And this is the same as the square root of negative 1 raised to the power of 2, and then times the square root of negative 1 raised to the power of 2. So this will give us I raised to the power of 4 equaling to, we found that the square root of negative 1 raised to the power of 2 is equal to negative 1. So this will be negative 1 times negative 1. And so this will be equal to positive 1. So now let's summarize everything. We said that I equals to the square root of negative 1. And then I to the power of 2 is equal to negative 1. And we also found that I raised to the power of 3 is equal to negative I. And then I raised to the power of 4 is equal to positive 1. So you take note of these. We are going to use them in the examples. Let's look at our first example. Let's say we have a complex number z equaling to 2 plus 3i. Let's find z raised to the power of 2. Z raised to the power of 2 will be equal to 2 and then plus 3i raised to the power of 2. And this will be the same as 2 and then plus 3i times 2 plus 3i. And now what we need to do is expand this. We shall get 2 and then multiply it by the second brackets. So this will be equal to 2 times 2 plus 3i, and then plus, now we shall get 3i and multiply it by the second brackets. So this will be 3i times 2 plus 3i. We used addition here because we have a plus sign in the first bracket. If it was a minus sign, then you subtract. So now let's open up the brackets. 2 times 2 will give us 4, and then plus 2 times 3i, which will give us 6i, plus 3i times 2 will give us 6i, and then 3i times 3i will give us 9i raised to the power of 2. So this will be 4 plus 6i plus 6i will give us 12i, and then plus 9 times, now we said that I to the power of 2 is equal to negative 1. So this will be equal to 4 plus 12i and then minus 9. 4 minus 9 will give us negative 5. So the final answer will be equal to negative 5 plus 12i. Let's look at another example. Let's say we have a complex number z equaling to 3 plus 4i. Let's call this z1. And then z2 equaling to 1 plus 2i. And then z3 equaling to 2 minus 5i. Let's find z1 times z2 and then times z3. Now in this case, it's better when we first work with z1 times z2, and then the result we get, we shall multiply it by z3. So z1 times z2 will be equal to 3 plus 4i and then times 1 plus 2i. So this will be equal to, we shall get 3 and multiply it by the second bracket. So this will be 3 times 1 plus 2i, and then plus, now we shall get 4i and multiply it by the second bracket. So we shall have 4i times 1 plus 2i. So this will be equal to 3 times 1, which is 3, plus 3 times 2i, which is 6i, and then plus 4i times 1, which is 4i, and then plus 4i times 2i, which is 8i to the power of 2. So this will be equal to 3 plus 6i plus 4i, which is 10i, and then plus 8 times I to the power of 2, which is negative 1. So we shall have 3 plus 10i and then minus 8. And so z1 times z2 will be equal to 3 minus 8, which is negative 5, plus 10i. Therefore, z1 times z2 and then times z3 will be equal to negative 5 plus 10i, and then we shall multiply this by z3, which is 2 minus 5i. So this will be equal to, we shall get negative 5 and multiply it by the second bracket, and this will give us negative 5 times 2 minus 5i, and then plus. Now we shall get 10i and multiply it by the second bracket, and this will give us 10i times 2 minus 5i. This will be equal to negative 5 times 2, which is negative 10, and then negative 5 times negative 5i, which will give us positive 25i. So this will be plus 25i, and then plus 10i times 2, which is 20i, and then 10i times negative 5i, which is minus 50i to the power of 2. This will be equal to negative 10 plus 25i plus 20i, which is 45i, and then minus 50 times I to the power of 2, which is negative 1. This will be equal to negative 10 plus 45i, and then negative 50 times negative 1, which is plus 50. And so z1 times z2 and then times z3 will be equal to negative 10 plus 50, which is positive 40, and then plus 45i. Now let's look at the division of complex numbers. When it comes to dividing complex numbers, there is what we call the conjugate of a complex number. Let's say we have a complex number z equaling to a plus ib. The conjugate of this complex number, which is z bar, will be equal to a minus ib. So we represent the conjugate by putting a bar at the top. And whenever we are finding the conjugate of a complex number, we need to change the sign on the imaginary part. Notice that before the sign was positive, and so we replaced it with a minus sign. Let's look at some examples. Let's say we have a complex number z1 equaling to 1 minus 3i. The conjugate of this complex number, which will be z1 bar, will be equal to 1 plus 3i. So the sign on the imaginary part was changed from minus to positive. Let's see another example. Let's say we have z2 equaling to negative 2 minus 7i. The conjugate, which is z2 bar, will be equal to minus 2 and then plus 7i. So that's how you find the conjugate of a complex number. Now let's look at some examples and see how we can apply this. Let's say we have 2 plus 5i divided by 3 plus 2i. How can you simplify this? In order to simplify this, we have to rationalize. And during rationalization, what we basically do is multiply both the numerator and the denominator by the conjugate of the denominator. The denominator is 3 plus 2i. And so the conjugate will be 3 minus 2i. So we shall have 2 plus 5i and then multiplied by 3 minus 2i. And this will be divided by 3 plus 2i times 3 minus 2i. So this will be equal to, if we expand the numerator, we shall have 2 times the second bracket, which is 3 minus 2i, and then plus. Now we shall have 5i times the second bracket. So this will be 5i times 3 minus 2i. And this will be divided by, we shall do the same thing for the denominator. So we shall have 3 times 3 minus 2i, and then plus 2i times 3 minus 2i. This will be equal to, for the numerator, 2 times 3 will give us 6, and then 2 times negative 2i will give us minus 4i, plus 5i times 3, which will give us 15i, and then 5i times negative 2i, which will give us minus 10i to the power of 2, divided by, now for the denominator, 3 times 3, which is 9, and then 3 times negative 2i, which is minus 6i, and then 2i times 3, which is plus 6i, and finally 2i times negative 2i, which is minus 4i to the power of 2. Now this will cancel with that, and so we shall have 6, and then negative 4i plus 15i will give us plus 11i, and then minus 10 times I raised to the power of 2, which is negative 1, and this will be divided by 9 minus 4 times I to the power of 2, which is minus 1. This will be equal to 6 plus 11I and then plus 10 divided by 9 plus 4. So we shall have 6 plus 10, which is 16, plus 11I divided by 9 plus 4, which is 13. And if we separate this, we shall have 16 divided by 13 plus 11 divided by 13 times I. And that's our answer. Let's look at another example. Let's say we have 1 plus I raised to the power of 3 divided by 1 plus 4i. How can we simplify this? First of all, let's work on the numerator. Now if you want, you can expand it normally. 1 plus I raised to the power of 3 can also be written as 1 plus I raised to the power of 2 and then times 1 plus I. And then after that, you expand this, and then you multiply the result with 1 plus I. But instead of doing this, I want us to use the binomial expansion. We know that A plus B raised to the power of 3 is equal to A to the power of 3 plus 3A times B raised to the power of 2 and then plus 3A raised to the power of 2 times B and then plus B raised to the power of 3. So in this case, we have 1 plus I raised to the power of 3. A will be equal to 1 and then B will be equal to I. So this will be equal to 1 raised to the power of 3 plus 3 times 1 and then times I raised to the power of 2 plus, now this will be 3 times 1 to the power of 2 and then times I and then plus I raised to the power of 3. So this will be equal to 1 plus 3. Now I to the power of 2 will be minus 1 plus 3 and then times I and then plus I to the power of 3, which is negative I. So this will be equal to 1 minus 3 and then plus 3i minus I, which is 2i. Therefore, 1 plus I raised to the power of 3 will be equal to 1 minus 3, which is negative 2, and then plus 2I. And so, this will be equal to, we shall replace the numerator with negative 2 plus 2I divided by 1 plus 4I. And at this point, we can rationalize. So we shall multiply the numerator by the conjugate of the denominator, which is 1 minus 4I. And also we shall multiply the denominator by 1 minus 4I. So for the numerator, we shall have negative 2 times 1 minus 4I, and then plus 2I times 1 minus 4I. And this will be divided by, now for the denominator, if you want, you can apply difference of two squares. Whenever you have, let's say, a plus b times a minus b, this is the same as a to the power of 2 minus b to the power of 2. Therefore, 1 plus 4i times 1 minus 4i will become 1 to the power of 2 minus 4i to the power of 2. And this will be equal to 1 minus 4 to the power of 2 and then times I to the power of 2. So we shall divide this by 1 minus 4 to the power of 2 times I to the power of 2. This will give us negative 2 times 1, which is negative 2, and then negative 2 times negative 4i, which is plus 8i, and then plus 2i times 1, which is 2i, and then 2i times negative 4i, which is minus 8i to the power of 2. And this will be divided by 1 minus 4 to the power of 2, which is 16, times I to the power of 2, which is minus 1. So this will be equal to negative 2 and then plus 8i plus 2i, which is 10i, and then minus 8 times negative 1, and this will be divided by 1 plus 16. This will be equal to negative 2 plus 10i and then plus 8, and this will be divided by 17. And so we shall have negative 2 plus 8, which is positive 6, and then plus 10i divided by 17. And if we split this, we shall have 6 divided by 17 plus 10 divided by 17 times I. And that's our answer. So that's all for today. Thank you for watching and have a nice day.